Hello everyone, I'm Mrs. Aparna from Modern College of Engineering, Pune. Today we are going to discuss Convolutional Encoder. The introduction. In block coding, we had seen that k-bit message blocks generates n-bit code word and the messages are produced on block by block basis in block coding. Whereas in convolutional codes, the message bits comes in serially and a buffer is used to produce the code word. The convolutional encoder generates redundant bits by using mod 2 convolution. The encoder code rate is 1 by n bits per symbol and is viewed as a finite state machine. The convolutional encoder consists of shift registers having mod 2 adders, multiplexers that form the output. Here, to find out the code rate, we have small r, that is the code rate, is equal to k upon n into bracket k plus m, where capital M stands for memory of the encoder. Here the constraint length is defined as the number of shifts over which a single information bit can influence the encoder output, or it can be treated as the number of shift registers. Here we have the example of a convolutional encoder. Over here there are 3 shift registers MK, MK-1 and MK-2. Out of these, MK is treated as the input and these two, MK-1 and MK-2, are the states. So there are 3 shift registers, so the constraint length is going to be 3. Here it is given g1 of x is equal to 1 plus x square. So from this we can write down g1 as 1 plus x square. And g2 of x is 1 plus x square, so it is mk added with mk-2. The output is v1 and v2. This is v1 and this is v2. So we'll find out the output v1 and v2 for the input bit pattern 101011. So the input is written in polynomial form as 1 plus x term is 0 plus x square plus x raised to 3 term is also 0 plus x raised to 4 plus x raised to 5. Now to find out the output v1 of x written as m of x into g1 of x. Actually here it is v1 and v2. So I'll just write here with a pen. This is v1 and this is v2. So this is v1, this is v2. Then we have, I'll come back to the arrows. Okay, so we have the arrows here. Then input is this what we have seen. v1 is m of x, that is the input, into g1 of x, and v2 is m of x into g2 of x. So this is how we have to multiply it. v1 of x is coming out to be 1 plus x cube plus x raised to 7, and v2 of x, which is equal to m of x into g2 of x, is equal to 1 plus x raised to 5 plus x raised to 6 plus x raised to 7. So the input given to us was 1 0 1 0 1 1. Output v1 v2. Now here remember v1 and v2 are written together. So you have to find out the coefficients of x raised to 0. Over here x raised to 0 coefficient is present, so it will be 1 for v1. Over here v2 is also present for x raised to 0 coefficient, and thus we write it as v1 v2. Similarly x raised to 1, here x raised to 1 is present, so it will be 1. Here it is not present, so it will be 0. So v1 v2 is 1 0. Likewise x raised to 2, it is 0, 0. It is not present both ways. X raised to 3, 1, 0. X raised to 4, 0, 0. X raised to 5, 0, 1. Now here we are not mentioning x raised to 6 and x raised to 7 deliberately because the inputs are, there are only 6 bits input. So we have to write the corresponding output only. We move on to the next. Okay, this is the reflection spot. Now let me tell you what is the reflection spot. Reflection spot, over here you will be asked one question and the options are given below. I'll take a pause and you have to answer the question. We will discuss the answer after the pause. So the question is, what is the constraint length of the convolutional encoder shown above? So I'll take a pause. Okay, so the options are 1, 4, 3, 2. So the constraint length, as we had discussed, is the number of shifts. It is equal to 3. I hope you might have got it. We are now moving on to the convolutional code state table. That means from the encoder, we have to design our state table. This is very easy. MK is the input. Here, MK is the input. MK minus 1 and MK minus 2, as discussed earlier, are the states. So here they are written as present state and here they are written as next states. Over here we have 4 states denoted as A, B, C, D. 0, 0 is denoted as A, 1, 0 is denoted as B, 0, 1 is denoted as C and 1, 1 is denoted as D. Now here for each state, input 0 and 1 combination is taken. So if you can see, for B also 0, 1 combination is taken, C also 0, 1 combination is taken, D also the same. Now we have to find out the next state and the output. So for the next state, what we have to do is, present state is MK minus 1 and MK minus 2. For the next state, the contents of MK are moving to MK minus 1 and the contents of MK minus 1 are moving to MK minus 2. So present state is 0, 0, input is 0, so the next state is going to be content of MK is moving to MK minus 1, so this 0 is going here, so it will be 0 here. 0 from here is moving to MK minus 2, so it will be 0 for MK minus 2. So you just have to shift. Output V1 and V2 is written as, V1 is written as addition of MK, MK minus 1 and MK minus 2. And V2 is written as addition of MK and MK minus 2. So if you see there, and one more thing to note is that while adding, we are only considering the present states. So over here, we are considering the present states and not the next states. So V1 is addition of all 3, that is 0 plus 0 plus 0. This is mod 2 addition, so it is going to be 0. V2 is addition of 0 plus 0. It is 0 again. So next we are going on to the input 1. Present state is 0, 0, input is 1. So the next state will be, this is moving here, 1 is moving in the MK minus 1 position and this 0 is moving to the MK minus 2 position in the next state. So it is going to be 1, 0. And the output is 1 plus 0 plus 0 for V1, that is 1. And for V2, it is 1 plus 0, that is 1. Next, B, present state is 1, 0, input is 0, next state will be 0, 1. This 0 is moving here, this 1 is moving over here. So it will be 0, 1. Output V1, V2. V1 is addition of all 3, that is 1. V2 is addition of 0 plus 0, that is 0. Then the next present state is 1, 0, input is 1. Next state will be 1, 1. It is written 1, 1. Output is 1 plus 1 plus 0, that is 0. And V2 is 1 plus 0, that is 1. Next, C, present state is 0, 1. Input is 0. So the next state will be, this 0 is moving here, 0. And this 0 is also moving to the next, that is 0. So the next state will be 0, 0. and the output is 0 plus 0 plus 1, that is 1, and 0 plus 1 is going to be 1. Present state is 0, 1, input is 1, next state will be 1, 0, output is 0, 0. Here present state is D, 1, 1, input is 0, so the next state will be 0, 1, output is going to be 0, 1. And the last one, you can see present state is 1, 1, input is 1, and we are having next state 1, 1 and output as 1, 0. Now the reflection spot, again the question asked is, what is the output when the present state is 1, 1 and the input is 1? I'll take a pause and I'll show you the state table also. So you tell me the right answer. So what is the output when the present state is 1, 1 and the input is 1? The option is, all these options are given, the correct answer is 1, 0. See, this is 1, 0. Okay. Now coming on to the next, we have with us the convolutional state. I'll take the arrow option. We have the state table with us. From that we are going to draw the state diagram. So these are the 4 states A, B, C, D. Present states 0, 0, B 1, 0, C 0, 1, D 1, 1. Now we have to see how they are going to be formed. So present state is 0, 0, input is 0. Input 0 is written here. The next state you are going is headed with an arrow. So the next state we are going to is 0, 0 and output is 0, 0, which is written to the right of the slash. We'll take another one. Present state is 0, 0. Present state is 0, 0. Input is 1. The next state we are going to is 1, 0, 1, 0. It is going to next state, that is 1, 0, and output is 1, 1. Okay. Likewise, we are going on to the next. Present state is 1, 0. Input is 0. Next state we are going to is 0, 1. So the arrow is going to 0, 1 and output is 1, 0. Then present state is 1, 0. Input is 1. Next state is 1, 1 and output is 0, 1. Present state is 0, 1. We are going on to this one. Present state is 0, 1. Input is 0. Input is 0. The next state we are going to is 0, 0 here and the output is 1, 1, which is written to the right of the slash. Then present state is 0, 1, C state, input is 1, the next state we are going to is 1, 0, see the next state is going to 1, 0, output is 0, 0. Then present state is 1, 1, input is 0, the next state is 0, 1 and the output is 0, 1, written here. And the last one, present state is 1, 1, input is 1 and next state is again 1, 1, so it's going on to the same state and output is 1, 0. So this is the present state. The arrow is showing where it is going to the next state. The input is written to the left of the slash and the output is written to the right of the slash. So this is how the state diagram is formed with the help of the state table. The references which I have referred is Burnett-Sklar, Digital Communication Fundamentals and Applications. I hope you have understood the concept well. Thank you.